7th of July. Welcome to NFE's continuous program on webinar where we share knowledge on electrical safety. So NFE, National Federation of Engineers for Electrical Safety, we are one of the fastest growing society in India. In less than 18 months, we have done 25 physicals seminars, which is sometimes we call it workshop. So we have associated with Bureau of Indian Standard in spreading the knowledge on new electrical code of India. We have done over 200 webinars and we have six chapter, over 1,500 members. So no other society in India within 18 months have achieved this. So we're working very closely with National Building Code. We're working with BIS and other AHPI and other societies to spread across on awareness on electrical safety. So if you're visiting our website, as I was mentioning, member can access to a lot of other previous webinars that we have conducted. You can access to the articles and blogs. The mission and mission of the our NFE is very clear: to make every electrical installation free of accident. And if you see today's, again, focus on free of accident in critical areas of hospital. Our mission is very clear that every engineer getting accredited for products and personal certification, which shall focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product, and installation by competent and qualified manpower using quality resources, including product, process, and procedures. This is a very clear vision and mission. We are working towards it, and in every program you can see our commitment on vision and mission is demonstrated. As I was mentioning, there are three different type of membership that we have. We have individual member, just 1,000 rupees, and the corporate member is 5,000 rupees an annual, and MSME is 2,500. So I would urge my friends who have joined now, participating in this webinar, to access to our website and become a member. And in just 2 weeks back, that is in July, we just concluded a webinar on cable sizing. And it was a wonderful, well-received webinar. And we spoke about understanding the CEA regulation. So this was done on 13th of July. The last Saturday, we had OSH, the Occupational Health and Safety, by our Mumbai chapter president, GS Bavejaji. So this was also well received and it was very useful. So all these recordings are available in our website. You can access to this if you're a member. And today's webinar, Electrical Safety in Hospital, Enhancing Safety in Group 2 Medical Allocation with Medical System. And once again, good morning to everyone. My name is Dominic. So I founder of NFE, and also I'm focused on conducting webinars, events, and marketing, branding. That's what I do in NFE. So today's webinar, Enhancing Safety in Group 2 Medical Location with Medical IT System. So delighted to have you all once again. And today is focusing on critical topic that impacts very core of patient's care and safety. Repeat, the subject talks about patient care and safety. In medical environment, especially in group 2 locations where patients are particularly vulnerable, ensuring the highest standards of safety is not just a priority, it's a necessity. Medical IT system, when I say IT, isolated terra. So medical IT system play a critical role in achieving this, providing reliable and secure framework that protect both patients and healthcare professionals. Today, we will explore the latest advancement, best practices, and innovative solutions designed to enhance safety of these high-risk environments. Our esteemed speakers who are experts in the field will share their insight, experience, and latest research and research findings. Your engagement and participation crucial. Please put up your questions, and we have our president of NFE, Mr. Kumar, will attend to your questions. I thank you once again for joining today's webinar. And I would like to take an opportunity to introduce our speaker, Mr. Kumar, who is also the president of NFE. He is very actively involved in ETD 20, ETD 30, and ETD 50, and also National Building Code. So where he is playing an important role in bringing his international experience into our codes. He's also a member of International Electrical Code, TC64, TC81, and AC37. So today's webinar is sponsored by his company called CAPE. They are the knowledge partner of today's webinar. We have a speaker from Finland. So due to time differences, we have recorded both the speakers' video. So Mr. Gopakumar will introduce, then probably he will play the recorded video. So Timo Ohtonen founded the Finnish health tech company in 1981 with a group of electrical engineers. He and his team have enhanced the electrical safety of hospital Group 2 premises and are actively engaged in international networking and cooperation. Timo is also involved with the World Health Organization, WHO, and the International Federation of Hospital Engineers International Technical Working Group. This group aims to develop hospital construction internationally, particularly by promoting countries with weaker infrastructure. Ohtonen and his team consult regarding the critical safety of Group 2 premises. He has developed 5th generation of Finnish MVV insulation monitoring systems, adhering to international and Finnish standards and addressing hospital needs of the special request. Mr. Ohtonen possesses extensive experience in professional electronic and electrical safety. We have third speaker, Mr. Kimmo. Mr. Kimmo Konttinen is the technical manager of PPO-Elektroniikka Limited. He brings vast experience and expertise in medical IT systems, electrical engineering, and professional electronics. He has worked closely with Mr. Ohtonen for over 22 years. Currently, the head of company's electrical work and participates in activities in the National Hospital Technology Association. He keeps abreast of international legislation, development, and communicates with the hospitals and companies in the field. He is also responsible for technical advice and has developed a concept through which PPO-Elektroniikka Limited provides orientation and support activities for international partners. So, ladies and gentlemen, these are our speakers, and Mr. Gopakumar will address in the welcome address. I would ask him to join us and also introduce the video of the speakers. Over to you, sir.
Thank you. Thank you very much, Mr. Dominic. Let me share the screen first. Yeah, I hope the screen is visible and it is in full.
Yeah, now it's full, sir.
Yeah, thank you. Thank you. Good morning to all the participants. As usual, we have a very interesting number of participants today. We are gaining, most of our webinars nowadays have more participants. We are sorry that sometimes the numbers are more than the capacity of our group. I think 2 weeks, 3 weeks back, one of the program, there were some complaints that participants are unable to log in because the maximum capacity is about 500 numbers, and then it is automatically diverted to YouTube and other links. Anyway, good morning to everybody. Today we will be discussing about electrical safety in Group 2 medical locations. But before going to the subject, I would like to make a small introduction about this, what exactly we are discussing. Now, handling electricity in hospital, it's a very critical subject. It's not like handling electricity in other locations, because in medical location, the chance of fire is extremely high because of more oxygen in the area, presence of alcoholic substances in the area. Also, the shock chances are very high because of it's a wet area. The skin is bypassed. The conductive fluids and materials are bypassing the skin, so the criticality is very high. Similarly, electromagnetic interferences, electrostatic discharge, and electrostatic attraction or accumulation. All these are hazard, or all these can create hazard in medical location. Through our various webinars, we were addressing subjects one by one. We had 3 weeks back, 4 weeks back, we had a program of medical IT, medical equipment verification, especially with the help of the product manager from Fluke. So today we are going to explain another subject, which is medical IT, medical isolation or isolated system. So as you are aware, the criticality, it's very, very, medical IT is a very critical subject. Any hazard or any small incident can become a big hazard very quickly. I'm sure most of you must have seen the videos which we used to share during our program, the fire in ICU, air conditioner fire in ICU, and so on. So basically, the fundamental idea starts with developing the standards or developing good engineering practices to handle the hazard. IEC 60513 it's a very old standard which talks about the fundamental aspects of electrical safety standards for medical equipment. So the medical equipment standards are made based on the identified risk in this particular standard. This standard actually explains the methods to identify a hazard. The severity level of each of the hazard is set on the standard. Decide on acceptable risk level, how much risk, because making 100% safe, an installation 100% safe is impossible, as you know. By risk mitigation methods, we can reduce the chance of an accident. So basically, deciding on acceptable risk levels, that means we should accept some level of risk still. Avoidance of fault and control integrity of levels, achieving acceptable risk levels, surpassing specified requirements, treatment of risk in IEC 60601 series. This is a very, very important standard, 60601. It talks about the quality and performance requirement of medical electrical equipment, which we say ME, or medical electrical system, which we say MES. So the performance requirement of ME and MES is set in this particular standard IEC 60601 for almost all kind of biomedical or medical electrical items. Fault conditions are defined in the standard single fault philosophy, very important. Single fault philosophy. I show you the definition of single fault later. So basically, based on this risk assessment, product standards are developed. Example, IEC 60601. Process standards are developed. Installation and environmental standards are made, and application standards are developed. So basically, the entire environment, how we have to handle the risk, what we should do, what should be the environment, what kind of, with respect to electrical system, for example, what kind of electrical ME and MES are required, what kind of performances they should follow, what kind of electricity supply is required, what kind of performance these equipment should withstand, all are very well defined in the respective standard. Now, for example, I'm just showing you the definition of single fault condition. Single fault condition means a condition of medical electrical equipment in which a single means for reducing a risk is defective Please note, it's very important. A single mean of reducing, there is a chance of a risk, and there is a means to reduce the risk, and that means is defective. That means, there is a fault, or a single abnormal condition is present. This single fault condition can exist in several ways. It can be mechanical, chemical, electrical, or whatever it is. The medical electrical equipment shall be made and installed and maintained in such a way that they are able to deliver the performance which they are supposed to do during single fault condition. That means even during a fault condition, the device must operate, something like that. Similarly, the power supply, for example, IC 607710, this is our IS 17512 standard, explains in case of a single fault in the power supply, this is about the power supply, not about the equipment. A total loss of power shall be prevented. This may be achieved by provision of two independent supply lines and or an UPS supplying the medical IT system. The purpose of showing this particular slide is this part of the standard is explaining about an UPS supplying the medical IT system. Unfortunately, in several places, what happens is UPS are being used as a medical IT system, which is wrong. UPS is a different item. UPS ensures that in case of a single fault, the power supply continuity is ensured by the UPS, whereas medical IT system is a different subject. Similarly, if you look at these standards, in different places, you can see the single fault condition is explained. The single fault condition means, for example, a protective conductor. You see, one of the single fault condition is failure of a protective earth connection. As you are aware, protective earth connection means you have an equipotential bonding zone within the medical location. And the protective earth connection, protective earth conductors must be connected to a common bonding bar. These are very well there in the standard. You can refer it later. Now, for example, I'm showing you the catalog of a biomedical equipment made by GE. And this catalog is taken from the international manual of the manufacturer. I would say it's written extremely good. You can see here some of the parameters. Maximum line resistance means the impedance of the line, the incoming lines should be within this particular limit to ensure automatic disconnection or to ensure safe operation of the particular device. A power input must be separated from any other which may generate transient. All equipment installed, then it also talks about the equipotential bonding, how to make equipotential bonding. Also in several places of the manual, for example, grounding conductor will be of the same size as feeder. Please note that this document is from USA. So instead of earthing, they use grounding. The ground will run from the equipment back to the power source main grounding point and always travel in the same conduit with feeders. Please read it seriously. The ground, that means the earth, protective earth conductor, will run from the equipment back to the power supply source. The source can be an UPS or a DG or a transformer. Source main grounding point, that means the neutral grounding system, the neutral grounding point of the system, and always travel in the same conduit with the feeder. This is the correct and perfect method of making a connection. On the other side, I am showing the manual from an Indian manual. I have put as spoiled. I am showing the name of the manufacturer purposely because, as you know, that we were trying to indirectly tell the manufacturers that because of your mistakes, equipment are in trouble, but most of the time they don't care. So you see here in the previous one, you can be sure that the equipment manufacturer has very clearly explained what the hospital or what the user should do. And here also they have explained what the user should do, but totally in a wrong way. This manual says there is an UPS, and the UPS you can see here neutral to separate earth pit. Then there is an earth box, and somewhere they have put as you can see here the earth measure should be less than 1 ohm. we had a chat discussion with the manufacturer, engineers from the manufacturer. What they say is each of this, there are 4 earth electrodes, connection to 4 earth electrodes are required, and each of these earth electrodes should have a resistance of less than 1 ohm. So basically, they are totally violating the fundamentals of electrical safety, violating the fundamentals of the recommendation of their own standard. For example, these medical equipments are made based on the standard IEC 60601 Part 1. There is an IS standard. The standard very clearly explained. For example, if the fuse is 13 amps, the impedance should be 200 milliohm. And if the impedance is more than 200 milliohm, then the standard says there can be a touch voltage exist. So this part I am just skipping. If you want, I can share you the screens later on. You can see here circuit breakers or fuses having a current rating of 13 amps or lower. Total protective earth impedance up to 400 milliohm is acceptable. In certain case, it is 200 milliohm or sometimes 400 milliohm. Now, if it is a touch voltage can appear on earthed conductor accessible part if the protective earth resistance is greater than 400 milliohm. So basically, the standard is explaining about the efficiency of protective equipotential bonding and the maximum allowed resistances in those particular locations. But the issue is, you can find such explanations in several parts. But the issue is, if anybody, any hospital follows the instruction, a wrong instruction from the manufacturer, such as the one which you are seeing in the screen. I'm so sorry to show the manufacturer's name, because I tried explaining them, but they don't care. They claim that what they ask is correct. So basically, if anybody, a hospital follows this kind of recommendation from the manufacturer, you can be 100% sure that you are violating the basic fundamental requirement and you will not achieve safety. Now, coming back to the medical locations. Our standard National Electrical Code or IS 17512 explained the subject. There are 3 categories of 3 groups of location: Group 0, Group 1, Group 2 location. The explanations are very much given in the standard, and the recommendation of different medical location, what kind of groups you should set, is also very well explained in the standard. Medical IT system is very critical in Group 2 medical location, especially for equipment. Those are life-saving, because the disconnection of power supply during the first fault could be dangerous. So you can see I'm moving the cursor. Shall not be automatically disconnected in the event of a first fault. That means in case of the first fault, still your power supply should work. Now I go to the presentation made by PPO-Elektrotechnik. One moment, let me share the screen first.
Good afternoon, and
The problem with audio. No audio we can hear.
No audio, sir.
unfortunately, we are both traveling a territory without
Is it
GSM
audio
coverage.
is good
Yeah,
now?
now it's fine. Now it's fine.
We have to over the wire. Good afternoon, and greetings from Helsinki, Finland. I am Timo, Ohtonen, CEO and the founder of PPO-Elektroniikka Ltd. We are honored to have been invited to this webinar. In this presentation, I will speak about medical IT systems with insulation monitoring in critical hospital premises. Our technical manager, Kimmo Konttinen, has prepared slides about the standard for this presentation. Unfortunately, we are both traveling in a territory without GSM coverage. So this time we have to do this over the video. Two are the most critical facilities where medical devices are used for heart-related functions. The failure of the medical device may cause immediate danger to the patient's and staff's life. The stakes are incredibly high, as even momentary interruptions in electricity supply or electronic device multifunctions can potentially lead to fatal electric shocks, jeopardizing the safety of both patients and healthcare staff. The common belief is that only 220 volt causes an electric shock. That is not true. Even relatively small voltages can pose significant dangers when current traverses the heart directly. Currents as low as 10 milliamp passing through the human body can induce muscular paralysis, which can swiftly progress to respiratory paralysis. Ventricular fibrillation, a potentially fatal cardiac arrhythmia, can manifest with currents slightly exceeding 20 milliamp. Remarkably, even minute currents in the order of 10 microamp have a probability of trigger ventricular fibrillation or cause pump failure when applied to a specific heart precision. Electrical leakage currents occur in both old and new electrical devices due to multifunction, age, and poor design. Common reasons for insulation faults include back connections, damaged cable insulants, and defective components. Fast technological development and the rush to launch medical equipment create new challenges. New equipment may cause disturbances in power network and other electrical devices. Please note that a residual current device that switches the electricity off does not give a pre-warning. It is not enough to guarantee safety. This is how it all started. Our company, PPO-Elektroniikka, was founded in 1981 to develop a system to improve electrical safety in operating rooms. Our first generation insulation monitoring system was completed in the same year. Our system was installed at Helsinki University Hospital, and it revealed a significant failure. There were many more medical devices with electrical current leakages that had been expected. Hospitals had even more than 20 device alarms a day. The pilot project brought up the electrical failures were a risk to patients, staff, and other operating room equipment. At the request of hospital engineers, our first digital insulation monitoring device was launched in 1983. In Finland, insulation monitoring became mandatory 1983. And finally, in other Europe since 2015. No operation will be performed in Finnish operating rooms if insulation monitoring is not in use. Since 2015, insulation monitoring has been required in all operating rooms and other critical care areas in all countries in the European Union. Still, there are very different solutions in Europe, and not all meet the standards. Here is a short summary of the standards. IEC 60364-7710 standard applies to electrical installations in medical locations to provide safety to patients and medical staff. A medical IT system must be used for final circuits, supplying medical electrical equipment, and plans for life support, surgical applications, and other electrical equipment in the premises. Installing at least one dedicated medical IT system is mandatory for each group of rooms serving a similar purpose. These systems must incorporate an insulation monitoring device compliant with IEC EN 61557-8 standards. Furthermore, every medical IT system must feature an acoustic and visual alarm system, strategically positioned for continuous medical and technical personnel monitoring, ensuring real-time awareness through audible and visual signals. What are IEC 60364-7710 requirements for special installation or locations, meaning medical locations? A medical IT system must be used in group cables of Group 2 medical facilities that supply medical devices and medical device systems in the treatment area. In Group 2 medical facilities, the group wiring of the sockets supplying life-sustaining medical devices or medical device systems must not automatically switch off the supply due to the first fault. The contact voltage of the second fault must not exceed 25 volts, or the second fault must be switched off according to the standard. The medical IT system must be equipped with isolation level monitoring device for the medical facility according to standard IEC 61557-8. The overload and temperature conditions of the transformer feeding the medical IT system according to standard IEC 61558-15 must be monitored. It is also recommended to use the insulation fault location system in the medical IT system. The insulation fault location system helps in locating momentary faults in particular. In an insulation fault location system is used, it must comply with Annex A or Standard 61557-9. What are mandatory functions provided by MED-IMD? The insulation warning indication shall take place at the latest when the insulation resistance has decreased to 50 kiloohms. For MED-IMDs with adjustable response value, the lowest setting shall be over 50 kiloohms. Local insulation warning have to be there. This function shall include the measurement of the insulation resistance of an IT system, including symmetrical and asymmetrical components, and assessments of this resistance and local warning. For each medical IT system, an acoustic and visual alarm system incorporating the following components shall be arranged at a suitable place, so that it can be permanently monitored by the medical staff. A green signal lamp to indicate normal operation, a yellow signal lamp which lights when the warning indication of the insulation monitoring device takes place. It shall not be possible for this light to be cancelled or disconnected. An audible alarm which sounds when the minimum value set for the insulation resistance is reached. This audible alarm may have provisions to be silenced under alarm conditions. The yellow signal and the audible alarm shall be cancelled on removal of the fault and when normal condition is restored. Remote insulation warning. This function shall include the measurement of the insulation resistance of an IT system, including symmetrical and asymmetrical components, and assessment of this resistance and a warning output. Indication of the interruption to the system to be monitored. An indication of the loss of the connection to the system to be monitored and of the connection between the IMD. Information about the value of the insulation resistance. The MED IMD shall provide information about the value of the insulation resistance. The information can be provided in form of meter, a display, or via data communication. Some point of global situation and challenges. Although Group 2 healthcare facilities might be isolated from the national power grid and equipped with medical isolation transformers, monitoring and hazard alerts often must be more adequately addressed. These premises might rely solely on rudimentary residual current device offering limited protection. Such devices only provide notification after damage has already occurred and cut off electricity to all connected devices within the fuse group. Global practices are variable due to a low level of expertise, lack of regulation, a reluctance to invest, and change established ways. Installation know-how, inadequate training measures and planning. This is how the system works in Finland and Europe. The electric power network of the operating room is separated from the electrical grid with a medical isolation transformer. The insulation level monitoring system monitors all the electrical devices connected behind this transformer. Units control the insulation level of the IT system, transformer load, and the temperature, as well the continuity of the protective earth 24/7. The equipment indicates the faults and problems before dangerous situations arise. This gives time to replace the defective device without breaks in the operation. How an adequate insulation monitoring ensures electrical safety. The system notifies of a fault early and informs of the faulty device on the screen and with the sound signal. The operating room staff can replace the faulty defective device. The alarm remains in the system's memory and can be transferred to a different system, such as a nurse station or hospital automation system. The system also indicates a broken PE wire. After an outage, medical equipment is left without a protective ground and insulation level monitoring without adequate protection. PE continuity monitoring is a unique solution developed by PPO. A proper insulation monitoring system offers safety, efficiency, and cost savings. The leakage of electrical current is an invisible killer without any visible signs. A proper insulation monitoring system protects the patients and personnel from electric shocks. It prevents electrical fires and burns, ensures that unnecessary downtime can be avoided, ensures that life of surgical equipment is extended. Acquiring an insulation monitoring system is a long-term investment. The price is low in relation to the value. It is a matter of human life that cannot be measured in money. Finnish insulation monitoring systems are built to last. With a lifespan of 10 to 15 years, and in some cases even 30 years. We have hospitals in Finland that still rely on devices we manufactured in the 80s. When you consider the lifespan of the investment, it equates to just a few cents a day, making it a cost-effective and reliable choice. Some notable issues. A piece of equipment that causes a short circuit or residual current can trigger a protective system upstream and, in doing so, shut down other, possibly life-sustaining equipment. Thus, paying particular attention to how each unit is supplied with power is necessary. The absence of continuity monitoring for the PE wire means that a fractured wire may go undetected, re-rendering the insulation monitoring system ineffectual. We must address such vulnerabilities comprehensively to strengthen electrical safety in healthcare settings. Today, operating room is full of electrical devices. Serious hazards have to be prevented and minimized in every possible way. The obligation is both legal and moral. The International Consortium of Investigative Journalists in 2019 wrote, manufacturers, doctors, and other potentially linked more than 1.7 million injuries and nearly 83,000 deaths to medical devices in reports to US regulators over the last decade. Insulation monitoring is one of the most efficient measures to prevent dangerous situations. Here is a case example how operating room staff should operate when a faulty equipment is detected in the operating room. A faulty device is connected or detected. The monitoring device detects fault and alarms. An alarm is shown in the OR wall panel. The faulty device is removed and it's sent to repair, and information to maintenance team has been sent. A new device is connected and the operation will continue. Here is a case example of installation in Finland. Insulation monitoring system installation for 20 operating rooms. What is required? Medical insulation transformers, 40 pieces, insulation level monitoring device, 40 pieces, protective earth wire monitoring device, 160 pieces, insulation fault locator device, 160 pieces, system monitoring panel, 40 pieces. What is required of a modern system according to the IEC EU standard? Mandatory is insulation monitoring device, which monitors the insulation of a floating IT network, leakage and current, transformer load, and the temperature of the IT transformer. Mandatory is also system monitoring panel, which indicates any insulation level alarms, line controller alarms, test lead faults, transformer overloading, and temperature alarms. Recommended components are protective earth fire monitoring device, which monitors the continuity of a floating IT network protective earth. Note, this unique unit monitors PE wire continuity 24/7. Also recommended is insulation fault locator. It locates any insulation fault in the floating IT network. How to support global development? We are now globally at a point where global safety measures are being developed due to the constantly increasing awareness and prioritizing of patient safety. So international legislation is being implemented in different countries to meet current requirements. However, it requires much work. International cooperation, training, and the introduction of new ways of working. It also requires willingness to use them. Implementation should also be controlled, and sanctions for neglect should be determined. In addition to saving human lives, operating room outage will decrease and leading to efficiency and cost reduction. Commissioning inspection should always be carried out before a new installation is implemented, or addition or changes are made to an existing building. Training and maintenance are topics that need much more attention and detailed discussion. Here is the checklist for operating room management. How to ensure that electrical safety on an operating room is proper. A modern IT system with an insulation monitoring system has been installed. A reliable and cooperative supplier who provides design support and training. Training, motivating, and encouraging the OR staff to understand the purpose and principle of the protective system and to know how to act in emergencies. Clear instructions. Appointment of responsible staff members. Electrical equipment should maintained and tested regularly. International Federation of Hospital Engineering has published many of our articles in their yearly issues. 2017, we wrote of the basic of insulation monitoring. 2019, we went a little bit deeper and described a little bit more about a proper insulation monitoring system. 2022, we wrote how important proper guidance and investment in training are for the usability and efficiency of the safety technology. When the staff understand the operation of the equipment at a sufficient level, the best possible result is obtained. Regular training provides the necessary skills and knowledge and the ability to use electronic medical devices safely. The existing hazards should be discussed with real examples. 2024, we shared our point of view on the most comprehensive and safest way to implement medical IT systems with insulation monitoring and what should be considered in the future. We also shared comments from our international partners to create more global picture. It is worth noting that protective solutions have yet to be universally adopted, but promising developments in legalization and knowledge are steering a path towards international adoption. Our company, PPO-Elektroniikka Oy, is a pioneer in insulation monitoring technology in the medical Group 2 premises. Since 1981, we have delivered over 30,000 IMD systems worldwide. In addition to our main solution, insulation monitoring system, we tailor unique technology solutions for fire safety, fire data and control, OR lighting solutions, and positioning and tracking solutions. I thank you for your attention. This was naturally a very short review of a very specific technology. I hope anyway that you got something out of this. I'm really sorry that I'm not able to answer for your questions right away, but we will be at your proposal right away in the beginning of August when we are back in the civilization, meaning GSM coverage. Thank you. Hope to see you again.
So that is the presentation from PPO. Unfortunately, they could not join because of the time difference and it's holidays going on all over Europe. I think we have questions. Dominic sir, you are available? We have few questions. Let me try to answer the questions one by one. There are some questions requested by the anonymous attendee. Generally, we don't entertain those questions. What is the equivalent, Mr. Sitarama Murthy is asking, what is the equivalent Indian standard of IEC 60601 and IEC 60364? 60601, which is the product standard for ME and MES. This is IS 13450. There are several parts. Then 60364 is in IS 732. Part of medical location is in IS 17512. All IS standards are available. They are freely downloadable. You can create a username password in the website and you can download the standards free of cost. So then we have a question from Mr. Nageshwar Rao asking, attended, not received any certificate. Mr. Rao, we are not providing. These are very informative, very, very basic webinars which we are conducting, and we are not providing any participation certificate because in the beginning when we were giving participation certificate, these were sometimes used by the members. What we finally understood is These are very fundamental, basic information, and providing a certification or certificate for participation is not really good. So we stopped it. Mr. Ajit is asking a question. In hospitals in various spaces, OPD, general ward, ICU, are spaces monitored for gas percentage parameters? I think it's not related to electrical. Let us dismiss the question. Mr. Mubarak Khan is asking P continuity monitoring, how it is achieved in presence of multiple outgoing and incoming earth lines. Of course, you should monitor all these lines. It's a critical subject. It's all these lines are to be, the continuity resistance are to be monitored. What is the cost of insulation monitoring device and the delivery time? It depends on the capacity. It depends on how many channels of outputs are required, and it depends on several parameters. So the cost can be anything between 3 to 4 lakh rupees up to maybe 7, 8 lakh or even 10 lakh rupees. It depends on the system. Mr. Narendra is asking, do we have any installation protocol to install IMD for an existing hospital? I mean, steps to be taken or followed. Of course, you need to make a survey. You need to find out basically physical spaces are required, wiring provisions are required. Basically you need to make a survey and you need to finalize it. Mr. Pradeep Dave is asking, do you recommend isolation transformer unearthed mode? Of course, medical IT is in unearthed. It's an isolated or electrically separated circuit, and the secondary side of the isolation transformer is insulated. So it's isolated system. Some anonymous attendee, how overcurrent and short circuit protection is given to isolation transformer when it is mandatory medical IT system not to have overcurrent protection in upstream and downstream of the feeder. Of course, monitoring is required. Overcurrent monitoring is necessary. So you can find the information in the respective standard. Then insulation, Mr. Pradeep Dave, IMS is to be installed after isolation transformer. Yes, of course, it's a complete system. So the complete system consists of medical isolation transformer, medical insulation monitor, then the fault locator for each of the output channels, and the protective earth continuity monitoring system. All these systems together, including the temperature measurement of the transformer and the overcurrent measurement. And in addition, please note that when we say medical IT or medical isolation transformer, these are very special transformers with very low leakage current. The performance required is very high. Normal transformers probably may not meet the requirements of medical IT. Full form of IT stands for Isolated Terra System. There are some simple questions. Is it a demo of these devices possible? Okay, there are only simple questions. Okay, somebody is asking, what is the working principle of insulation monitoring system? Basically, there are two types of power supply system. Earthed system, where the safety is ensured or fault protection is achieved by protective equipotential bonding and automatic disconnection of supply. That means in case of fault, the protective device should disconnect the supply within certain time. Whereas for critical application like the one for in medical group 2 location, a disconnection of supply may create a dangerous situation to the patient. So disconnection of supply shall not happen. For that particular purpose, continuity of supply during the first fault is necessary, and the medical IT system ensures that the supply continuity is ensured during the fault. The insulations are monitored. You can find out the faulty circuit. Still, you don't need to trip the circuit in case of an earth fault, and you can continue the system. So that is the basic. There are okay, Mrs. Pallavi is writing, in India, the cost is main factor. Any specific electronic device which is reasonable in price, which is used in Europe, can be used by small hospitals to avoid any mishaps in operation theater, since India is a cost sensitive region. Yes, of course, India is a cost sensitive area, but we should also think that here, if we go for the cost cannot be compromised, or cost cannot be connected with the life of the patient. So we should first understand whether the cost is important or the life is important. Of course, there are hospitals, those who have medical IT system, but not everywhere. There are some repeated questions. Let me go through some important questions. Present days, medical equipment are electronic generating third harmonics, and in three-phase distribution, neutral current rises heavily, while neutral is half size in 3.5 core cable. Okay, Mr. Panchal's question, it's not a question, it's like a statement. What he says is medical equipments are nowadays electronics producing a lot of harmonics in the neutral. Of course, yes, there are, the safety measures are different. It has nothing to do with the medical IT. How much, Mr. Sanjeev Kumar is asking, how much penetration is there of insulation monitoring system related to ME in India? Is there any data available? How awareness can be made? Okay, so the question of Mr. Sanjeev Kumar is how many hospitals or how many percentage of the operation theaters these are used? I would say probably 0.5% or 0.05% of the total hospital or total group 2 locations are using medical IT. It's very, very rare. Even some of the big hospitals are trying to implement it, but very slow, very, very rare. So far, there was no legal requirement, but now after the implementation of, after the publication of the NEC 2023 as well as the Safety Regulation 2023, the awareness is going up because in case of non-follow-up of CEA regulation or non-compliance of NEC, there is a chance that the management of the hospital can be put under the Section 146 of the Electricity Act. So there is an imprisonment and fine applicable if these are not used, and if there is an accident. So there is very important, Mr. Mubarak Khan, there is very important subject, and we must create a widespread awareness. How do we create awareness in doctors and hospital owners? Can NFE take this initiative to create a nationwide campaign of physical meeting by NFE members? Of course, we are trying. We keep on trying. Let's see. Probably, we will have some break even somewhere. Mr. Karol, is it possible for you to paste the links of those articles that were on 22 and 22, 21 and 22 slide? Of course, the video will be uploaded in the website. Please have a look on the video. Mr. Panchal is also again explaining about the neutral burns because of low size and create fire. How you consider this? I have experienced this in many places, not only in hospital but also offices. Of course, unbalancing as well as the modern electronics create a lot of problem in the neutral conductor. So you can refer IS 732, where the protection against harmonic currents are explained. The easiest way is, you know the size of the neutral conductor. You should measure the current of the neutral conductor. and switch off the phase conductors if there is an overcurrent in neutral. The only safety measure possible, the safety measure, I am not talking about power quality, the safety measure is if the current is exceeding the capacity of the line, you should disconnect the supply. You can find it in IS 732. You please search as a neutral current or harmonics current or protection against a harmonics current. You will get the answer. Mr. Ajit Sheshadri is asking, my question is general for all hospitals, can be answered by anyone in hospital admin. I don't know what is the question. In a medical IT system, an isolated, Mr. Davis is asking, medical IT system, an isolated system is used. How is the PE conductor connected? Of course, the exposed and extraneous conductive parts must be bonded together to the equipotential bonding system. IT system says the live conductors are not connected to the earth. So only the live conductors are unearthed. Otherwise, the rest of the exposed and extraneous conductive parts are connected to the equipotential bonding system. What will be the touch voltage permissible limit in G2? Of course, it's 25 volt. So these are some of the questions. We still have a lot of questions, but the questions, more than questions, they are like kind of statements from several of the members. We also have, as you know, we may not be able to look at the questions if they are posted in the chat box. So I'm just having a look on the questions in the chat box. So somebody is asking any new emergency electrical devices are available to avoid the hospital accident. Mr. Somnath, please be very careful. There is electrical safety is not achievable by putting one device or a kind of device. There are claims in the market. People claim or manufacturers claim that I have a magic equipment, a black box. If you put the black box, all safety can be achieved, and my black box is connected to the IoT, you will get SMS. All these claims are there. We have published a lot of blogs or a lot of information in our blog. I request you to go through our blog. So there is no magic device to solve all the electrical safety problem. So the only solution is it should be designed, erected, selected, erected, verified, and maintained properly. Then only electrical safety is possible. So there is no much questions, Mr. Dominic.
Yes, sir.
Yeah.
I think we have almost 20-25 questions. I think that has been covered. So if anybody has further more questions, probably Lakshmi has been sending the speakers, that is Mr. Gopakumar's mail ID, and also Deepak from Cape. He's also there. He can also answer your questions. So please, Lakshmi, you can type Deepak's mail ID there and Sir's mail ID, so that if any further questions are there, people can get back. And also, I want to thank Cape being the knowledge partner for this. The reason we are giving NFE and Cape, these are the people who have been sponsoring our various workshops and seminar across the country. We have in a company like Polycab, Fluke, Sonel, Siemens. So we have been, this is one of the deliverables that we are promising, that we will be conducting regular webinar for them if you are partnering with NFE. So those who are here as a participant from companies, you can probably recommend to your company to come, because NFE is a non-profit organization. And objective is to reach out to schools and colleges and corporates to create awareness on electrical safety. To do that, we need a lot of funding, a lot of sponsorship programs. So I'm sure Mr. Gopakumar would have told you that we are launching the book fundamental on electrical safety push to reach out to all these schools and colleges. I think Tara, you want to do something? Do you want to? I think, okay. So I would urge people who are there as from the corporate to come forward and support NFE's initiatives program, and you can become part of this webinar program also. We assure you that your products and solutions also reach out to our members. We have almost 1,500 members now, and those who are not member of NFE, kindly, the link is given in the chat box by Lakshmi, and I would urge to just click and log in and become a member. So thank you so much. We did in a record time. I think it was a short 12 p.m. And we look forward on the 10th. So with 10th, we are talking about power quality. I think, Lakshmi, did you share the next webinar link also to the participant?
Yes.
Yeah, please share that so that they can join for our next webinar by Hari Balakrishnan from Zenitsa, who's going to talk about power quality. So thank you so much. We look forward to see you on 10th of August. Till then, be safe. Have a wonderful time with your family. Happy weekend. Thank you so much. Bye-bye. Thank you.